Hello, my name is Laurie Pierce, professor in the opticianry program at Hillsborough Community College in Tampa, Florida, and I work in the education area for IOT. I'm very happy to be with you today to talk about the benefits of this very unique design concept, which is Camber Steady Plus Progressive Addition Lens, the best choice for independent eye care professionals, invented and innovated by two independent optical companies, Younger Optics and IOT. The Camber concept is that base curve is important. Base curves matter. For every prescription, there is a perfect base curve. Years ago, we talked about this with corrected curve theory and even may have studied Vogel's formula. We have to ask ourselves, when introducing a new technology, are we introducing a new technology just for the sake of a new technology? We should ask ourselves, why is this technology needed? Is it to gain marketing advantage, or is it an actual breakthrough, a real breakthrough technology? And I think you will agree after seeing this presentation, this brief video, that absolutely this is a breakthrough in technology. In ophthalmic optics, we know that for every power, there is a correct and best base curve. In this diagram, we are using a -5 diopter lens in a CR39 material. Notice for this lens power, there is an ideal base curve designated in the red. Within this range, the optics are pretty much optimized for the power. But as you can see by the purple line represented visual acuity, it falls off very quickly as the line deviates from the ideal base curve range bracketed by the red lines. And you can see that there certainly is a quick drop in visual acuity. And you can notice within the bubble shown at the top, within the ideal range, you get good visual acuity. To the left of the ideal range, the base curve is too flat and the vision suffers, especially in the periphery of the lens, where the obliquities and aberrations occur. And then to the right of the proper base curve range, you can see that the visual acuity once again suffers because the base curve becomes too steep. And looking at the seams, the lenses in these top bubble examples, you can see that there's a big difference in the quality in the visual acuity from going off the best base curve. And when we look at the importance of base curve and understanding that there is a unique base curve that is perfect for every power, we have to think about it for a minute regarding progressive addition lenses. This is a unique situation. We're not talking about a single vision distance prescription. We're talking about a power that needs to be distance, intermediate, and near, and these powers are different from each other. Here, when we look at this graph, we would have a specific base curve range, and anything deviating from that range would hurt the vision, would have less visual acuity. Represented by the red curve, we also have another lens power in the near zone, which has its own corresponding base curve range. Therefore, we have at least two different base curve requirements because we have at least two very different powers, distance and near. You can almost look at the camber as made up of a combination of curves. If we were to simplify the idea, we can just look at it as two major curves, distance and near. When we look at the rotation of the eye and the required steeper curve on the bottom for near vision, the difference with the camber blank is that it is a variable base curve, requiring a steeper base curve for near and a flatter base curve for distance. When we look at this slide, we can see that a more accurate way to visualize the camber curve is to think of the different lens blanks as being from different sections of a spiral-shaped curve, which is shaped almost like an elephant's trunk. Camber has 8 separate base curves: a half, 2, 3, 4, 5, 6, 7, and 8 diopter bases. And you can see from this visualization that each of these come from a different section of the elephant trunk, if you will. A fun fact, when Younger and IOT were collaborating on this project, the secret code for the project was called trunk. Here, you can see the difference between a spherical lens blank on the left, used to make most freeform progressive lenses, and Camber's special lens blank on the right with a gradually increasing front curve. You can also see that on the standard single vision lens blank on the left, let's just say, for an example, a plus 6.5 diopter base curve was perfect for that middle range of the lens, that the spherical lens blank would have a 6.5 diopter curve throughout the entire surface. You can see on the right-hand side, given that same plus 6.5 diopter base curve in the central part of the lens, you can see that as the curves vary from the middle to the bottom, they get steeper, and from the middle area to the top, they get flatter, which is ideal for the best base curve for the distance and the near zones. As you can see in this slide, the difference of the surface is very slight. Putting an imaginary black line that stimulates a camber blank shows the differences from a standard blank and the camber blank are very subtle. When we add this curve, you can see the difference between the single vision blank and the camber blank. It's a very, very slight change cosmetically, but it makes a big difference visually. That old saying, a little bit goes a long way, is certainly true in this case. Curvatures decrease in the upper part of the camber blank and increase in the lower part. The differences are very subtle when we look at a single vision lens blank and the camber variable lens blank. You can see in this example the single vision lens blank compared to the camber looking through a grid is a very subtle change. And cosmetically, when looking at the profile, there's a very subtle change as well. Even though cosmetically it's very hard to distinguish the differences with the naked eye, the increase in visual acuity and maximizing the optics makes a big difference. This is an example where a little bit goes a long way, certainly holds true. When you think about it, this isn't so strange because people don't notice the progressive front curve on the traditional progressive lenses either. We also know that in our profession, patients and clients prefer flatter lenses, and you can see in these examples the difference between using a single vision spherical lens blank and a camber variable lens blank. The typical base curves would be chosen for 2.5 add and a 2 1/4, 3 1/4, and a 4 1/4 base curve. And you can see with the camber lens, there's a flatter base curve, a better profile, and we know that our patients and clients want flatter, more appealing lenses in their finished prescription. Now we'll see a short video showing how the final camber prescription is made from the Camber blank and IOT freeform surfacing software.
The Camber lens blank improves on the spherical lens blank by offering a continuously increasing base curve to better match the different powers in each zone of the finished progressive lens. The state-of-the-art digitally designed back surface of the lens is calculated in mutual accord with the unique progressive design. The back surface design is further enhanced when desired by a complete set of individualization parameters. The digital design, combined with the individualization parameters, are processed together of curves on both sides of the lens, creates the finished Camber progressive lens, an advanced digital lens that accommodates an expanded prescription range, offers better cosmetics, and yields user-preferred near-vision performance.
Next, we're going to look at some data from some clinical studies that were conducted. Younger Optics and IOT commissioned a series of studies with the University of Madrid in Spain. In this study, the only difference between the two comparison lenses was that one of the pairs of the lenses was processed from traditional spherical lens blanks, and the other was processed using Camber blanks. Exactly the same high-level design is processed on the standard single-vision lens blank and the Camber blank. The wearers use each lens using the same material, same base curve, and the same frame for the same period of time, which was 1 week. This is a double-blind study, meaning the wearers didn't know which pair of lenses was which, and the testers conducting the study didn't know which of the lenses was which. The wearers were asked to compare lenses after trying them both. When asked, which lens do you prefer the most? 66% of the wearers preferred the Camber overall. This is really an amazing result, since remember, the only difference between the two finished prescriptions was one was processed from a single vision lens blank and the other from the Camber lens blank. When asked, in general, was the adaptation easier with one of the two pairs of lenses? Here, 83% of the members of the wearer trial said that the adaptation to the Camber seems to be easier. Once again, when almost a 4-to-1 preference in a wearer trial is noticed, something special must be happening. And remember, the only difference is the lens blank. The next question asked was, what is the near vision of the two lenses better with one or the other sets? Here the results were significant. Nearly 94% of the wearers perceived near vision to be equal or better with the Camber lens blank. As ophthalmic lens designers, this may be the most important slide in this entire presentation. Remember, the heart of the idea for Camber came from the basic optical principle that base curve corresponds directly with the lens power. Here we see why this is so important. The gentle sloping, ever-increasing base curve of Camber really shines and shows its benefits in the near zone. Here, between two pairs of glasses, the only difference being the Camber front curve versus the traditional single vision, by a factor of almost 15-to-1, wearers preferred Camber. Incredible. And here you can see the benefits for your patients. Camber Steady Plus progressive lenses can be personalized for each wearer. They incorporate IOT's digital ray path 2 technology and advanced ray tracing system, and Steady Plus methodology that eliminates the swim effect in progressive vision lenses. You can see that these benefits using the Camber Steady Plus. All of these things that the patients will feel. Fitting heights are 14, 15, 16, 17, and 18 millimeters or variables. Next, we will see how the Camber digital designs are available in 4 different configurations. When you look at the standard configuration on the left, this is a balanced design. I personally wear this design myself, and it is outrageously fabulous. In fact, when I received them and I put them on, I was looking for aberration and looking for distortion, and I couldn't find any. And that's the balanced design. However, some of your patients may want a specific, equally high quality design that focuses a little bit more in 3 different areas. You can see on the top one, this would be for an alternate design configuration for near vision on the right-hand side top. And in the middle, maximized for distance vision, and on the lower right, maximized for intermediate vision. And when you look closely, you'll see the difference between the balanced on the left and the dashed lines and the solid line showing the alternate configuration differences. This is a game changer where the dispenser or the optician can ask the patient if they have a visual preference for distance, intermediate, or near, and it makes the product much more versatile and adapts to most wearers. Additionally, Camber Steady Plus lenses have a wide availability to suit all of our patients' and clients' wants and needs, including hard resin, polycarbonate, trilogy, 1.6, 1.67, and 1.74 high index. Also available in clear, transitions gray and brown, and new polar. And finally, also available in the transitions drive wear. Now let's talk about what it takes to fit and dispense these very special lenses. Camber Steady Plus progressive lenses can be fitted like any other progressive lens. When fitting them, opticians should take accurate monocular PDs and fitting heights. If these are the only parameters you transmit to the lab, your lenses will be calculated with default positions of wear, that is vertex, tilt, and wrap. If you are not able to send those additional measurements to the lab, no worries. The defaults have been well tested and we know that they are good. If, however, you take and transmit any advanced measurements to the lab, they will be used to make a more tailored design for your patient. Advanced measurements for Camber Steady Plus include wrapping angle, pentoscopic tilt, and vertex distance. You're welcome to provide one or all of these measurements to your lab. If provided the near working distance and minimum fitting height, the corridor length, that can also be chosen by the optician in the Camber Steady Plus progressive lens. Pretty cool, right? And you may scan this to get more information. Also, please scan these QR codes on this slide to learn more about IOT's Digital Ray Path 2 technology, which is an advanced ray tracing system using the wearer's accommodative ability. It's amazing. Additionally, to learn more about the Steady Plus methodology, which are also included in the Camber Steady Plus progressive edition lenses. Thank you so much for taking the time to learn about Camber Steady Plus progressive lenses, the preferred choice of independent eye care providers. Our social media pages are filled with interesting information and educational content. Please check it out.